this video, we are going to look at the qualitative analysis of organic compounds. By organic compounds, we are simply talking about carbon, hydrogen, oxygen, nitrogen, sulphur, and then the halogens. And these halogens are the chlorine, the fluorine, the iodine, and then bromine. So let's first talk about carbon, hydrogen, and oxygen. How do you determine the presence of carbon, hydrogen, and oxygen in an organic compound? What you do is that, for example, if you have the organic compound here, you heat the organic compound. So you have to heat the compound. When you heat the compound, you convert all the carbons in the compound into carbon dioxide. And then you convert all the hydrogens in the compound into water. So when you are done with this, how will you determine the presence of carbon dioxide and water in the organic compound? What you do is that you pass the compound through lime. If you pass the compound through lime and then the lime turns milky, then it confirms the presence of carbon dioxide in the compound. Then you also pass the compound through white anhydrous copper sulfate. If there is water in the compound, then the white anhydrous copper sulfate will turn blue. If it turns blue, then it confirms the presence of water in the compound. For the presence of oxygen, there is no readily available test to determine it. So after determining the presence of carbon dioxide and then water, then you can convert them to their percentages to determine the presence of oxygen. To determine the presence of nitrogen, all you need to do is to do the sodium fusion test. In the sodium fusion test, you will add the organic compound. You would add sodium metal. Then when you heat the sodium metal, the organic compound is converted into its various ions. So the sodium in the compound, in the heating of the compound, will convert all the nitrates into sodium cyanide. Then if you add iron hydroxide to the sodium cyanide, it will turn Prussian blue. So if it turns Prussian blue, then it confirms the presence of nitrogen. For the presence of sulfur, after you are done with the sodium fusion test, what you need to do is to add lead acetate. So when you add lead acetate, the solution will turn black. When the solution turns black, then it confirms the presence of sulfur. For the halogens, you will still go through the same sodium fusion test. After you are done with the sodium fusion test, then the next thing you need to do is to add silver nitrate. When you add silver nitrate, it will convert the various halogens into their halide forms. Then after it is converted to their halide forms, then you add ammonia in excess. When you add ammonia in excess, what happens is that the excess ammonia will cause chlorine in the solution to precipitate as silver chloride. And then the bromine will precipitate as silver bromide. And then the iodine will precipitate as silver iodide. For the chlorine, in the presence of excess ammonia, it turns white. You will observe a white precipitate. And the white precipitate confirms the presence of chlorine in the organic compound. And then for the bromine, you will see a yellow precipitate, which is insoluble in excess ammonia. And then for the iodine, you are going to see the presence of a yellow precipitate which is also insoluble in excess ammonia. So sorry, for the silver bromide, it is a pale yellow precipitate. And then for the silver iodide, it is a yellow precipitate. How do you determine the structure of an organic compound? To, distract, to determine the structure of an organic compound, the first thing you need to find is how the atoms of the organic compound are bonded to each other. And then the second thing you need to determine is the distances between the atoms that are not bonded together. That are not bonded together. And also, the third thing you need to determine is the bond angles of the various atoms. And then the last thing is the stereochemistry of the various atoms. There are some special spectroscopic methods that helps chemists to determine the structure of organic compounds. And then the first one is the infrared spectroscopy. The infrared spectroscopy helps the chemist to determine what are the functional groups in the organic compound. So this one will help you to determine the functional groups of the organic compound. Then the second one is the ultraviolet, the UV, ultraviolet spectroscopy. Ultraviolet spectroscopy. And then the ultraviolet spectroscopy helps chemists to determine conjugated pi bonds. Now, for example, if you have, let's assume you have cyclohexane in this form, cyclohexene in this form, and then you also have another molecule here, which is cyclohexadiene. You can see that there is a conjugation in this compound, but there is no conjugation in this compound. However, both of them are alkenes. So in order to be able to distinguish between cyclohexadiene and cyclohexene, then you need to use a UV spectroscopy to determine the difference between the two. And then the other spectroscopic method of importance is the NMR. And the NMR is the nuclear magnetic resonance spectroscopy. And the NMR gives information on the carbon, and also the carbon-hydrogen framework of the compound. Then the last one is the mass spectroscopy. And the mass spectroscopy gives information on the molar mass, molecular mass, and also the molecular formula of the organic compound. So these are the four major spectroscopic methods that are used to determine the structure of an organic compound. Later on, I will do a video that covers every aspect of mass spectroscopy and then nuclear magnetic resonance spectroscopy, which is the NMR. Now, when dealing with organic compounds, one of the requirements is that those compounds must be very pure. And the purity of an organic compound is determined based on its melting point and then also the boiling point of the organic compound. So organic compounds tend to have very sharp melting and boiling points. So what are some of the methods that are used to purify organic compounds? The first one is distillation. So you can distill organic compounds to purify them. And this distillation is normally based on the difference in the boiling points of the compounds that are present in the organic compound. And then the second one is sublimation. So sublimation, the ability of the organic compound to be transformed into the gaseous state without passing through the liquid state. And then the next one is recrystallization. And then recrystallization is based on the principle that the organic compound dissolves when heated and then recrystallizes when cooled. So the difference in between its ability to dissolve, which is solubility. So the recrystallization is based largely on the solubility of the organic compound. And then the last one is chromatography. And there are different kinds of chromatography that can be used to determine. But the simple one that is used is the thin layer chromatography, normally represented as TLC. And in that one, what you do is that you find a basin and then you would fill it with a solvent. So the solvent makes up for the mobile phase of the chromatography. And then you use a chromatographic paper. So let's assume this is our chromatographic paper and you immerse it. But before you immerse it, you need to first determine the extent at which the mobile phase reaches on the paper by marking it out with a pencil. So this is the solvent front, and then you will spot the organic compound on the base of the solvent front. But the most important thing is that you are not supposed to use a pen to mark this line on the chromatographic paper. And this is because a pen itself contains other organic compounds that may interfere with the compounds on the original organic compound. Also, another thing is that this spot must not be too concentrated. If it is too concentrated, what will happen is that the various compounds will be separated and they will be very clouded on the chromatographic paper, and you want to avoid that. So you want to ensure that there is a pure separation of the compound. And then the last thing is that the solvent that is being used in the process of this chromatography must be lower than the baseline, which is the line that you have drawn. The organic compound must not be immersed in the solvent. Rather, by capillary, the solvent should be able to rise through the chromatographic paper to separate your organic compound for you. And so after the solvent moves to maybe a certain point here, then you would mark that point. By that time, it would have separated your organic compound into some layers. So I have a table here. Let's try and then write the inferences for the table under the various reagents that are used. So if there is presence of chlorine in an organic compound, when you put in silver nitrate, you would observe a white precipitate. And then in excess ammonia, the chloride ions are soluble. But for bromide ions in nitric acid, you are going to observe a pale yellow precipitate. And then in excess ammonia, bromide ions are insoluble. So insoluble. Then for iodine, you observe a yellow precipitate. And then in excess ammonia, it is also insoluble. So this is how you can differentiate between chloride ions, bromide ions, and iodide ions in an organic compound. Remdesivir, a broad spectrum drug, was identified earlier as a promising therapeutic candidate for COVID-19 because of its ability to inhibit SARS-CoV-2 in vitro. Circle and name all the functional groups on remdesivir. The first functional group is this functional group. And this functional group, so let's label it as A. A is the arenes, very easy to identify. And then the second functional group of interest is this functional group, B. And then B is an alcohol. And then the next one, you can see this functional group. This functional group is, let's say, C. And then C is an ether. Ether. And then the next functional group we can identify here is this functional group. And then carbon bonded to NH2. So let's say that is D. And that is an imine functional group. And then there's this functional group here. It is called a nitrile. So E. E is a nitrile. And also there is this functional group which is here. And then this functional group is F. So F is an ester. And apart from that, there is also this functional group here, Gen. And Gen is the imine functional group. Chromatography works on two main principles: absorption and partition. Complete the table below in some types of chromatography with the stationary, mobile phase, and type of principle used. So when you come here, column chromatography, the stationary phase of a column chromatography is solid. And then the mobile phase is liquid. The principle used is the absorption principle. Absorption. And then for a paper chromatography, stationary phase is liquid, and then the mobile phase is also liquid. And then the principle used is the partition principle. And then for the thin layer chromatography, the stationary phase is solid, the mobile phase is liquid, and then the principle is the polarity. Absorption. So here's absorption. And then for the gas liquid chromatography, the stationary phase is a liquid. It's liquid. And then the mobile phase is gas. And then the principle that is used is the partition principle.